on the 10th of November, and we're here to talk all things Power 10. Thank you to everyone who for joining and who's joining. I'm Daniel Fleetwood, the Business Development Manager at Evolution Systems. And today, I'm going to provide some insights into some of the new and exciting features of IBM's next generation of Power. But I'm not alone. I'm delighted to be joined by Jeff Borland, the Managing Director at Evolution Systems, and Matthew Goes, the Server and Business Strategy Manager at IBM. Good morning, guys.
Morning.
Good to see you. So, Jeff, Evolution, just quickly, Evolution turned 21 years old this year and has been a long-term business partner of IBM. So, tell us about when Evolution became an IBM business partner and why that, and how that happened and why.
Look, I think the core of Evolution Systems has always been around IBM I, which obviously runs on the Power systems, and the business has been really built on that foundation, and that's been at the core of the business ever since its inception 21 years ago.
Great stuff. And Matthew, you've been at IBM for almost 10 years, so probably still known as a newbie, starting out as a certified project manager professional, moving to product line manager for service solutions, and your current role as server business and strategy manager. Now, I know you've recently spoken to some very cool people at IBM regarding Power 10, Joe Cropper, Demetrius Penderakis, and Raj Krishnamurthy, just to name a few. So is this the most excited you've been about the latest generation of Power, you'd say?
I think so. As you say, I'm relatively new, so maybe I'm not the one to ask necessarily, but those guys we talked to, I talked to John Wise as well for SAP, and he's 40 years in the business, and he seemed genuinely very enthused. Power 10 doesn't just have, one or two new things, an incremental performance improvement. We're doing a lot of, we're adding a lot of new capability that I think is genuinely very exciting for where you would use Power 10 that I'm sure we'll get into.
Absolutely. So just some quick housekeeping. This is a live event, so if you do have any questions, pop them in the chat, and we should have time at the end. The session's also being recorded and will be available through our social platforms and our website. So if you are watching any recordings and have any questions, you can email them out and reach out via our social channels at any time. So let's get into it. Look, some of the headlines we've already seen are you ready to harness the power of 10? So my objective really for this webinar is to drill down and focus on 10 key insights and split them into 5 key topics and discuss how customers can really harness the power of 10 in their business. So let's move on to the first topic. I've got, with every new generation of Power, as we know, there's always improvements in performance and efficiencies, and in particular, the environmental aspect. So, and this generation is no different. We're seeing, 50% more performance and 33% lower energy consumption. Those stats are compared to the E980. So Matthew, how have they managed to, how do they manage to keep doing this? And also, how does the Power 10 chip stack up performance-wise against competitors such as, Intel's Cascade Lake or Ice Lake?
Yeah, so it's a really genuinely difficult thing to offer per core performance improvement generation after generation. As Moore's law continues on, and it becomes harder and harder to shrink the size of the transistors on the chip. You just don't get the free gains that you used to get. That having been said, Power 10, like Power 9 before it and Power 8 before it, offers around 30% improvement on the previous generation, just on the per core improvements. We're also fitting a lot more cores on because we're down to 7 nanometers now, so we can fit a lot on the chip. So it's genuinely a very impressive thing just to be able to maintain the consistency of improvements generation to generation. And as we had shared there by our MC, it's such that a 2-node Power 10 system has more throughput than any 4-node or otherwise Power 8 system that shipped. It's really a phenomenal improvement over where we were. And if you compare it to Intel boxes, it does depend on, there's lots of ways to do these benchmarks, but I believe it's about 2.5 times the performance per core of an Intel box, which, there are other things on top of that, but just as a straight throughput thing, that's a really impressive stat. I think we've really got a good handle on how to get this performance going.
Yeah, exactly. That's a big statement there from IBM and against its competitors. From my point of view, and a customer's point of view, when you then combine that Power 10 and with OpenShift containers, you're really going to get, or be able to provide exceptional efficiencies throughout the business, whilst significantly reducing the carbon footprints as well.
Absolutely. Yeah. I mean, that's the main thing about having more performance per core, right? You can do more with less. And when we say that you can fit in a 2-node system, 2 Power 8 systems, the main thing, I mean, obviously that's nice from an efficiency perspective, but that also means less electricity going in, and it means less rack space you have to take up. And it means just, I mean, a smaller footprint is a smaller footprint, carbon or otherwise. And that's a really nice thing to be able to boast. But that certainly does translate through to containerized workloads as well. I think 4 times the performance or thereabouts is what we boast for the number of containers you could run on a Power core versus x86. It's just strikingly efficient.
Yeah, it's incredible.
There we go, 4.1.
Yeah, you're close. Close enough.
Corrected.
And look, that really leads us nicely into the next topic, which is hybrid cloud. So we all know that hybrid cloud is becoming the new normal. And with Power10, customers are able to future-proof applications without starting from scratch, and also with the new shared utility computing, or Power Enterprise pools, it really is allowing customers to pay per use between private and public cloud as well.
Yeah, this is a big topic, and I'm sure we could spend the whole half hour on it alone, but I'll try and keep it brief. Power historically has been a thing that has been very good. I mean, as you guys know, IBM I is a workload that you could run an IBM I workload on a Power box that's bricked off. Literally, I heard a story of a system that was bricked off inside a data center, and when they couldn't find it, they had to tear down a wall they'd recently built to get to it to do maintenance. And that's a really kind of strong and good aspect of the system. But as you would have heard from IBM's marketing, we're kind of centralizing around this idea of a hybrid cloud, which is to say that there's a Red Hat layer for us. That's the common layer you interact with that lets you run your workload where it makes sense to run your workload. And what that means for Power systems is being compatible with that broader hybrid cloud story in a way that lets you do things on Power that Power is good for, without necessarily having to have a whole deep set of Power skills, and to be able to consume it in a way that is in line with the general drive towards consumption-based or cloud-like models. And so we could talk about it. We'll talk about it, I guess, further down here and there. But the main thing is that there is a push towards the integration of things like OpenShift and things like Ansible and things that are kind of platform neutral to help you use Power in a way that doesn't necessarily require the same level of skill you would have needed 5 or 10 years ago. Because, for example, with Ansible, you can go to the Ansible repositories on ansible.galaxy.com or whatever the site is, and you can see that the best and brightest minds in IBM with decades and decades of experience have been making playbooks to help you deploy IBM I, or to help you deploy SAP, or to help you deploy whatever it is on Power. And the great thing is you don't need to understand any of that. We had an example of a partner that was doing a SAP install. The reference is out there as Tamago, and SAP certifying an environment is very difficult, but that's okay. There's a playbook for it. They just ran it, and the environment's SAP certified now. So it's a really nice sort of way to take the benefits of the hardware, which are just unbelievably fast. I mean, yeah, as we see there, just absolutely insane performance, and use it without having to worry about the fact that comes with a different architecture. In terms of the consumption as well, we have a thing called Power Enterprise Pools 2.0, the sequel to Power Enterprise Pools 1.0, if you can imagine such a thing, which essentially just, you activate a base amount of capacity on a box, we ship it to you. I think that the minimum is strikingly low and usually not fit for anyone, but you can activate, say, a single core and a small amount of memory. And then when you're using that, it's free to you. There's no extra cost. But if you need to go above that amount, it's billed per minute. You have a pool of credit, you tap into it per minute as you would on the cloud. It's spinning it up, spinning it down, like on AWS, Azure, IBM Cloud, whatever. But it's done automatically. The machine's fully activated there all the time. And when the consumption dips back down at that baseline level, the billing stops. So it's a really neat way to kind of get that same model to account for those peaks and troughs, but to do it on premise. And as I believe, I don't think I'm talking out of school here, we have a statement of direction that we will have an option for those credits in the near future, where you will be able to redeem them on our Power VS offering on IBM Cloud as well. Yeah. So they will become hybrid capacity credits at that point.
I think one
So
of the
really-
one of the things that scares a lot of people sometimes around per minute billing can be if you get a rogue job that just runs away in the background. So I think it's probably important to have your monitoring and alerting accurate when you go into that sort of model.
Yeah. I think if you're a hyperscaler public cloud provider, I think you quietly love that problem when customers have it. You do what you can to prevent it, of course, in with good integrity and everything. But it's nice when it happens. But Power does have a lot of really good ways to control usage. We've always had a real focus on getting the most you can out of the box. There's things like shared pools where you can have 10 cores that are shared across 10 LPARs, and they will never together exceed that amount. So if they have different spiky windows, you can use them in a way that's really, really efficient. There are caps on LPARs so that they don't, go above any amount you define. It's important to have that kind of stuff set up, but in a way that practice is so well understood within IBM and our partner community. I mean, I'd be confident turning you guys loose on any customer that had that concern and know you would get it right in a heartbeat. So it is very important still, as it is in any cloud consumption model. Make sure you know what your workload is doing.
Just quickly, Matt, just to go back to what you were talking about, the playbooks, one of the myths that we often hear is skill shortage. I mean, there is, I guess, a global IT skill shortage, but more specifically around IBM AIX. But it certainly sounds like the playbooks and things around Ansible and OpenShift is going to address that skill shortage.
Yeah, I mean, I was talking recently, as Daniel said, I had a call with Joe Cropper, who is one of our master inventors and chief architects of our hybrid cloud solution. And he was talking about how there was a story he had at one of his customers where they had a graduate come out of university, and because they understood Ansible playbooks, Ansible is a language, if you will, they got a lens into how IBM I worked, and then were able to start working with IBM I in a productive way in 2 weeks. And I think that one of the things that's really good about the IBM I ecosystem is this expertise that exists there, that these people have been doing it for decades and decades and decades and can really do well with the system. But that it is a risk that you lose that once those people retire or move on or what have you. So it really is a good way to ensure that knowledge transfer happens in a way that not only lets you apply it practically, but gives you a way to understand it and reverse engineer and kind of understand what these people would do when they were in their, at the peak of their experience, how they would apply it. It's a really nice kind of way to do knowledge transfer and also just have that practical application of those skills even after that person has moved on.
Yeah, it's awesome.
And it really is about having giving customers from a customer point of view, giving them a consistent experience across the traditional on-prem and public and private cloud, regardless of what the operating system is, and being able to seamlessly move workloads across as and when they need to, which is fantastic. So we briefly spoke about in that topic OpenShift, and the next topic leads into nicely is SAP. And put simply, Power10 boasts already the best 8-socket performance, some 955,000 SAPs, which is significantly higher than its competitors, already ranked #1 in reliability for the last 12 years. And Power10 now has the largest scale-up capacity for HANA. So what is it that makes IBM Power work so well with SAP?
It really is it's just a staggering rap sheet, isn't it? I mean, the stats are better across the board. It's really interesting, but there's a couple of things that are really key. And SAP as a whole, there are people who are paid just to understand SAP, not even to do anything with it, just to understand it. And I won't pretend to be one of those people. But the main thing is that SAP is well, at least HANA, when we're talking about HANA specifically, which is what this benchmark was, it's an in-memory database, which means that at the very just foundational level, the speed at which you can move stuff in and out of memory becomes incredibly important. That's kind of your biggest choke point. And on Power, we have always had really, really good bandwidth between the processors and the memory, just a higher number, a higher throughput number than the competition. In Power 10, that is, we have a new thing called the Open Memory Interface, or OMI, that is, I think, pushing that throughput up to I'm gonna get the number wrong, but a terabyte a second or something like that. We're pushing it again, and with that capability will come a standard, the ability to introduce new technologies that take advantage of that standard. There are things we're talking about like memory pooling and what have you that are not out today, so I won't take time on them. But it's really about memory bandwidth as the main thing. The second thing is that the virtualization layer in Power is treated differently to the virtualization layer in x86. So when you're going to buy a solution for SAP, when you're going to buy infrastructure, you have the option of buying an appliance, if you will. You can buy a box that has been certified by SAP to be appropriate for a certain type of workload, whether it's OLAP or LTP or whatever, and know that it will perform to a certain standard because it's benchmarked. When you come to IBM and you say, I want to buy a power system, we don't have that model necessarily. What we have is a thing called TDI5 sizing, which in short, the responsibility for doing the sizing goes onto the vendor, goes onto IBM, instead of going onto SAP to certify it. And the advice from my betters in the US, when we first came out with this sizing, was immediately just double the memory to core ratio, just straight away. And the reason for that is that we can drive very efficiently a lot of workload on the box so that we don't need as many cores as you would in x86. We can do really aggressive sizing. And generally, I mean, aside from keeping costs down in a nice way, we also have these we have these extra kind of permissions from SAP to do things like run 16 SAP production instances on one box, where for the competition for x86, if you were to get over a certain size of database instance, you have to put that on its own dedicated box. And I believe the virtualized memory limit is about 6 terabytes. And on Power, it's about 24. So you can run these really large instances. You can run many of them on one box where you would have to split them out on x86, and you can use a lot less cores to do it. And so it's just very, very efficient as a platform. And as you said, we've got that 5 nines reliability stat. The I've forgotten the name of the people who rate it, but I think there's something like 8 minutes of downtime a year for a Power box, which in SAP terms I think is acceptable.
Yeah, absolutely. And the Power10 has the new memory architecture called Open Memory Interface. So that's obviously helping in memory apps such as HANA. So it's really
yeah. So full disclosure, SAP have not yet certified Power10. They got the box serial number 00001. They got the first one, and they're working on it. But with this kind of greater capability and this different standard comes a bit more time to get everything certified, understandably, I think. But when Power10, I mean, we have the benchmark there to show what the performance will be like. And once SAP certifies it, then customers will be able to use it. For now, it's just a much faster throughput, which is a terabyte a second. So thank you to my memory. And will come with additional capabilities in the future. We hope that, again, we'll have to go through SAP vetting. But there are things like integrated memory clustering is the name for it, where you'll be able to share memory between boxes and things like that we'll talk about when they come out. But it's a very cool new standard that will let us introduce new capabilities. For now, it's just fast as hell. And I think that's how we got to that benchmark result in such a kind of staggering way.
I never thought about it before, but I guess someone has to get serial number 00001. That must be an awesome box to have.
Yeah, I think so. I mean, SAP is in a way an ex-IBM company, a bunch of ex-IBMers that went to form it. So I think it's to them, it's probably a nice thing to still have that, that kind of respect from us, I guess.
Absolutely.
But it's just, I mean, Power is just brilliant at database. It's a relationship that totally makes sense and will continue to make sense, I think.
Absolutely. Absolutely. Look, our next topic is security, which is always a hot topic. And we're now seeing built-in encryption on the chip, which is providing out-of-the-box security with zero performance impact. So we're seeing built-in encryption and transparent memory encryption. So this must give customers, especially those with applications like HANA, like real peace of mind and huge benefits as well.
Yeah, I think so. There's a do we say? Oh yeah. So I think there's up to 4 times the crypto accelerators in Power10, and the reason for this is that we have this thing turned on that's listed there at the top called transparent memory encryption, which is this idea that when you're moving data between wherever and memory, it should be encrypted because that's a point at which it could be intercepted. And if it is not decrypted at that point, then it's vulnerable. Because when data is in memory, it has to be decrypted for you to do work on it, right? And so we've introduced this capability in Power10 that you cannot turn off, called transparent memory encryption. It's built into the system at a foundational level. All of our performance metrics assume that it is turned on because it has to be. And it essentially will, with almost no overhead, encrypt the memory in that step. Encrypt the data in that step when it's transitioning into memory. And the main thing that is kind of interesting about that for me when I was talking to Dimitrios, our CSO, is that it kind of takes the onus off the users to worry about this kind of stuff, which I think is kind of the old fashion of security. InfoSec used to be a game of stay active on the threats, have users understand how to do things properly and kind of be very active about your security. But the way that's much more effective, because a lot of this stuff tends to happen by accident, is just to take the assumption out of the hands of anyone and just make it happen. And so this doesn't require application recertification. It doesn't require any kind of toggling on or off. It's always on. If you buy a P10 box, you've got transparent memory encryption. And the logical question when you talk about transparent memory encryption that I tend to get is, well, okay, but it's in the memory and then it's decrypted so you can do work on it. So I'll just get it then. And we have this capability that you can see there called fully homomorphic encryption, which unfortunately does require changes to the application because it lets it's a supported capability in Power10 that I won't pretend to be able to talk about in any kind of real detail. But the very shorthand is it lets you do work on encrypted data while it's in memory. So at no point in transit, at rest, in memory, or being worked on, your data is always encrypted. And I mean, that's a pretty great standard of security once we can get to it, once application vendors start using this capability, which also does exist on Z, and I'm sure probably exists in some form or another out there in the x86 world. But we also have, while I'm here, I've got this nice reference here. The thing we often talk about as well in the same breath as this with security is quantum safe cryptography, which is just this idea that quantum computers are coming, they're going to break all our encryption straight away and all our data is going to be compromised. And people will say, well, sure, but quantum computers, as I understand it from your own advertising, IBM, are a long way away from being able to do that. So what's the problem? To which we say, they're a long way from being able to do it now. But if I steal your data today and technology improves exponentially, then in 5 years' time, I might have a quantum computer that can crack it open like that. No worries. And then I've still got your data, and I've got everyone's credit card numbers or home addresses or whatever it is that I managed to get. And I think it would be better if, I didn't have that. I think it would be better if that kind of data wasn't able to be broken in the future. So without going into a lot, we have an agreed to standard for support for quantum safe cryptography in Power10. So if you're worried about the future of quantum computers, and a lot of people, I think, reasonably should be, it's there as well. And I will stop now rambling about the slide, but the security story is really cool. It's a lot of capability with not a lot of requirement on users to understand it or to implement it. And I think that's a really good approach.
I think that the biggest challenge for security in any organization, isn't it? It's the individuals. That's probably going to be the biggest link, or the biggest weakness, I should say, in a lot of security, a lot of companies. It's educating users as well. It's always going to be a challenge.
It is. There's a. I was having a conversation just recently with one of my colleagues. There's a stat somewhere, and I'm going to get the percent wrong, but I know it's about a third of attacks that happen of breaches are ransomware, which means someone installed something they shouldn't have. Mm-hmm. They opened an email, they ran an exe, they did something that they should not have.
Yeah.
And it's not, it's tough out there if you're not an InfoSec professional. What do you know? You do the best you can, but one times in 100, you accidentally click the link you shouldn't have, or you open the email you shouldn't have, or whatever.
Yeah. They're getting very sophisticated now and getting incredibly, more difficult to spot. So, it's a good feature.
Yeah, absolutely. Yeah. Scary stuff as well, but great feature to have automated or switched on out of the box to give you peace of mind. So, look, our final topic, I'm conscious of time as well. Our final topic is AI. Now, we could talk all day about this, but we'll try not to. Now, look, during your talk with Raj Christian Murthy, he really hit the nail on the head when he said, this chip can do things that has never been done before. So with complex problems can now be solved with AI inference, and part of that is due to the matrix accelerator present on each core. So what can customers really expect from that?
So I would and could I could and would like to talk about this for half an hour, but you're right, we don't have the time. In short, for those who aren't familiar with the AI space, there's kind of two big areas. There's the training, where you take a bunch of data and you teach an AI how to, identify tanks or see fraud or whatever it is that you're doing with your AI model. And then there's inference, which is the kind of execution of that trained model. So they're very kind of different workloads in a not a foundational way, but they have very different requirements for how you do them. When you're doing training, you want to get those big fat NVIDIA graphics cards because they're really good at a thing called matrix math, which is just the multiplication of numbers by numbers in a matrix, which is foundational in gaming, and as it turns out in AI as well. So NVIDIA kind of already had these devices that were just brilliant for doing AI training. And when you're doing that training, because you want to get a model that is as accurate as possible, you want to have really high precision, which simply means if you have a number that is 99, you want it to be 99.9999999, as many nines as you can get. The more the better for precision. But if you train your model right, you don't need that level of precision when you're doing inference. You can do 99.999 and you'll get roughly the same results as if you did all the other nines. And the nice thing is it's a lot less computationally intensive. So what we've done in Power10 is we have this dedicated section of each core that is a matrix math accelerator. It's very, very good at doing low precision matrix math, so that when you go off and train your model and you bring it to your SAP HANA database or whatever that's sitting on Power, Power's great at databases, so it's not unreasonable to think you would, bring the inference to your data. It goes like the clackers. It just goes absolutely crazy. It's 5 times the performance of the Power 9 if you were to do the same thing. And I believe that I've seen different versions of it, but I think we think it's about 20 times more performant than x86 at the kind of high end. Which, you might make the argument, if I was to have a graphics card, I could get higher performance than that, to which we would say, yes, but one, it's ridiculously expensive. Good luck getting supply in Australia with all the Bitcoin miners, all the people in cloud who want it, all the gamers. Good luck getting graphics cards. And the second thing is graphics cards are really hard to manage. You kind of buy them as a whole thing because they, processors or CPUs have a big history of virtualization becoming increasingly mature and helping you divide things up really nicely with things like shared pools and all that sort of stuff. Graphics cards are kind of this ugly thing that you stick in and you use the whole thing or you use nothing. And anyway, this will be a shift in the industry, I think, where you'll be able to more often just do inference on the CPU and it'll be good enough. And in Power10, I've talked to some of our data scientists from our client engagement team. They say it's good. Not good enough, it's good. It's as good is what one of them is kind of, he's doing napkin math and he's like, yeah, it should be as good. We'll have to wait to get our hands on one to test that. But the kind of, that alone would be interesting, right? But the challenge with a lot of things on in this space is that it's much, much more, high performance, but the process of getting that performance out is really complicated. You have to do a bunch of optimization or specific conversion or whatever. So at the same time, we're doing this thing, or there is a drive towards kind of architecture agnostic models. There's a thing called Onyx, which the Onyx runtime, which essentially when you go and do that training, say you train it in, Azure on an A100. If you export the model after you train it into Onyx, you could then run it on a toaster, as long as that toaster understood Onyx, or a calculator, or Raspberry Pi in a submarine that's off the coast of Australia, or whatever. The idea is that your models that you train somewhere specific should be able to be applied generally. And so you can run them on Power regardless of where you train them, as long as they're Onyx compatible. Talking to that same data scientist, he said, yeah, Onyx is the standard. Onyx is the one, it's really good. It's the one everyone uses. So yeah, there we go. So you go and take the model that you've trained, pour the new data into it as it comes in. If you have a big database running very efficiently on a Power10, then, do your inference right there. It saves you the trouble of having to move terabytes of data around, especially if that data is frequently updating, and you can get the insights, on the spot where they are without having to introduce graphics cards and all kinds of other messy stuff. So it's genuinely very exciting. It's a really good time to be doing inference on, well, at all, but on Power10. And if you look at it in the broader picture of hybrid cloud, this idea that you would have a power system as part of your architecture that was the place where the database sat and the inference happened and what have you, it kind of fits into that bigger idea that you have this Red Hat layer that means you don't have to necessarily worry about how you're going to introduce that or manage that, or how you're going to kind of expand on that. The idea is that it should be very easy to include it because to some extent you speak the language of Red Hat. Who cares about all this hardware stuff? Just get a playbook for it. It's fine. Somebody who understands it really well already implemented it and they wrote it for you.
Yeah, really.
Efficiency all around.
Yeah, it's really taking power out of this idea of something that needs to be optimized in place as a standalone system into how it can work as a really, really foundational part of a broader system where essentially it just crushes the intensive workloads that you have and does it really cost efficiently, which I think, again, venturing into the field of personal philosophy here, but digital transformation, as people talk about it, the idea is it's do more with less. We have constant cost pressure everywhere. We really just want to drive down costs per user. And if you can buy some hardware that does it 5 times or 20 times more efficiently, or does 4 times the number of containers, or whatever it is, whichever of these performance stats that's interesting to your use case, and it's no harder to implement, that's budget that you free up. It's budget you can use elsewhere. Maybe you can give your IT people a pay raise for once.
Very nice. It's my understanding that Power10 AI is built into Power10, so you don't need specific models like previous generations, like the AC models. No. It's in there.
It's every core, every single core. So if you need more matrix math capability on your workload, just add another core to the pool.
Awesome.
The more cores you have, the more matrix math you have, accelerators you have.
And I'm also saying that we can. Sorry, Jeff. We can now bring non-Power customers across without any disruption, or can both.
So you could bring, for AI specifically, if you've trained your model and exported it to Onyx, you can bring it from anywhere. No worries, no problems. It will run on Power.
Cool.
Matt, I was at Think a couple of years ago when Ginny Romedy mentioned that it's not necessarily the technology, it's more the application and how businesses would actually apply AI in regular daily workloads. Are you seeing that change? Has there been a swing towards AI adoption?
Yeah, it's such an interesting topic. When we introduced the AC922, the dedicated training box in the Power portfolio, I spent a lot of time in this. I was relatively new to it, and we would go out to customers and we would say, "Hey, we have this amazing system that just goes crazy." Again, the performance on training on the AC922 is just staggering for reasons I won't go into. But we went to a large financial customer, and those of you who have heard me talk or some of my colleagues talk may have heard this before, but they had a fraud detection model. There was something like 80 fraud cases in 1 million customer records. And they had a very complicated manual kind of thing that they had set up, a detection algorithm that they had set up that had a certain amount of accuracy. I can't quite remember the percent, but say it got it 90% of the time. We came in and with this box and a dedicated data scientist spent 4 weeks and we beat it. I think we beat it by something like 20%. We were getting much better detection. And we said to them, here it is. Here's how we did it. Here's how it works. Here's how you can use it. And they said, that's great. And they never used it. And the reason is that data scientists in the years and years and years ago, ancient history, 3 years ago in AI, were treated as this kind of distinct and separate thing that was difficult to integrate with the rest of the business. There was business process and there was data scientists. We could see they were getting great results, but we didn't really know how to just make that operational. But these days, there's a lot of work in place from, people like Red Hat, our client engagement team and data science teams inside IBM, the broader ecosystem, the Googles and Microsofts and everyone's, to try and get to a point where we can just treat data scientists like developers, because we understand DevOps, right? Mm. And we understand now there's things, CI/CD workflows, there's a whole support stack for developers to let them quickly do development and deploy it into production safely and without interruption, so that we can get the advantage of their brilliant minds and kind of give them the freedom to interact with business process dynamically. AI Ops treats it the same. We should have data scientists that know how to safely and effectively deploy their models into production in a way that is non-disruptive and beneficial to the business. And that practice, AIOps, was something that people were talking about 3 years ago, but now it's a really mature kind of a more mature idea, and there are a lot of tools to support it, and there's a lot of live implementations to support, and a lot of experience that we have been involved in ourselves. In IBM, we've seen a lot bigger uptake than we used to see in this area. People are using models in production where before it was kind of something that was limited to the Netflixes and Amazons and people who had, that kind of scale of problem. But yeah, in short, it's a lot more consumable these days, and it's because of the business process behind how we use data scientists and trying to treat them less like these weird alien things that if you talk to one, you might think they are. Sorry, data scientists, you're easy to make fun of. You're all brilliant.
Any questions from the data scientists? Look, we've come to the end of the five topics. So just seeing if there's any questions. I believe we have some questions.
I guess while we're waiting for the questions to come in, it seems to me like with all the things that we've been talking about, C levels will be jumping up and down at this. I mean, there's cost savings across the board and efficiencies. So it looks to me like this generation of the new Power server will be able to sort of extend beyond the current Power, community, if you like, so into the wider audience. I think there's a lot of potential.
I really think so, and I think that if you look at IBM strategically, if I try and look from the outside in, we've recently done this big Kyndryl spin-off that I'm sure people have seen in the news, and declared that our intent is to focus on the channel, on our partners like you guys. And I think that there's a really good reason for that, because as a C-suite, I can read these facts and say, oh, great, it's going to save me whatever, the TCO story, the business process story, whatever. That all sounds great. But I'm not going to plan that project, and I'm not going to really understand that. So what I need is somebody to come in and have that conversation with me in a way that I can understand how the business case stacks up and also how I can get it deployed. And so we really have this focus on the channel as a way to have those conversations. And we have a lot of support for those kinds of engagements, like things like the Systems Garage. We have a dedicated team of worldwide greatest minds from lab services and tech pre-sales and what have you, that were previously called the AI Center of Competency, I believe, and are now the Systems Garage, who can help deliver MVPs and demonstrate this stuff actually working. And, there's a lot of support inside IBM for that kind of activity. But yeah, I think it's very exciting as long as you can make it seem real, and we can demonstrate that it is in a very practical way. So I see we have a question on screen here from Brendan.
We do.
Yes. In short, Brendan, yes.
Excellent.
I believe the Matrix Math Accelerators are part of the cores on the Scale Out box. I think Raj said this in his talk, which I believe is I hosted it, so I know it's a publicly available talk that the replay can be sent around if you guys want it. Yeah. The idea is that if you want just a small inference box in your environment somewhere and you want it to be cost efficient, buy a 10.12 or whatever we end up calling it. I don't know what the naming scheme is yet, but a 10.22 should be perfect just to drop in for your inference box.
Yeah, brilliant. Any other questions? Let's bring them through.
Server market. Stuart, I think we'll see IBM expanding into the server market to compete more with x86. I think that the hybrid cloud story, I wish I had this slide. Sona, who's running the show behind the scenes, I apologize I didn't get this slide to you, but IBM has this really nice, I might actually see if I can find it while I'm talking, but this really nice story about hybrid cloud, which is this one chart that you'll see from IBM is everywhere. And this idea is that you should be able to run things wherever it is best to run them. Yeah. And so when you ask the question, do we expand in the server market to compete more with x86? Yeah, I mean, what we're going after now is not Power workloads. We're going after workloads that make sense on Power.
Yeah.
And what we understand that historically has been a thing where, this workload runs great on Power, but all my shop is x86. The conversation we would have is, well, let's talk about how you can make your x86 processes better then. The Ansible automation story is great. Even if there's no Power involved, it's great. The Red Hat story is great. I think there's a Red Hat study talking about the number of VMs in the cloud that are deployed on Linux, and it's something like 55% are running on Linux. And with that comes the ability to use the suite around the operating system. So let's talk about that. Let's talk about how you can get automation going and kind of the efficiencies of the DevSecOps processes as Red Hat would outline it. And then when you're all set up and getting these advantages in a much greater pace and, you know, much more confidently, why not introduce Power? You already understand how to talk to it. You know Ansible. That means you can talk to Power. It's fine. And I think that we really will see, you know, it's something that we have a bit of work to catch up on. If I was to have this conversation 2 years ago, I would say there's a lot of work going on. Now, a lot of this stuff is really real. You can really do it in anger. And if you guys want to have a conversation about it, I can bring in the garage to prove it. You know, they'll show you it working. They'll do an MVP at no cost to you guys and show you this does work and it works well.
Nice. Okay. Do we have any more questions?
We have one thing. Sorry, I'll throw it into the mix. There's a thing called the Hybrid Multi-Cloud Showcase that we have at Worldwide. The Systems Garage has access to this system. It's a AWS Azure Power Z environment running VMware and Power VM and, you know, OpenShift. They've just crammed as many technologies as they can into the one environment, and they show it off to people. I think it's really cool.
Yeah.
Just because we can.
Yeah.
Just because we can. Yeah, I mean, you know, we really want to prove that we can.
That's right.
Superb. Look, I think we've gone over a bit, but I think we've really covered a lot of things today, and we know that we could talk all day about this stuff. So I personally am looking forward to getting my hands on a Power10 and possibly, or hopefully, putting it onto the roadmap for the Evolution private cloud. Thank you to Jeff and Matthew for your time and sharing those valuable insights, and to everybody that stuck around until the end. If anyone has any other burning questions, please reach out via our social platforms. And yeah, see you again on our next webinar. And Matthew, we'll definitely have you back.
I look forward to it. This is real fun.
It was always going to be a touch the surface in the time we had, but that was a really good
half an hour. Guys, yeah, that's aggressive.
Yeah.
Let me hold on. Sorry, if I can I drag it out by one more second? I found the slide now. So let me just share this. So this is from Joe Cropper's presentation that we had. The replay is available. This is the slide. Sorry, it's a simple slide, I know, but the idea is this is the story. If you talk to anyone in IBM, I did a presentation to a customer the other week, and straight after me was someone from our software area of the business. They started with the same slide. This is the IBM story. Everything works with this.
It's a great slide, isn't it?
Yeah, that common layer of interaction, that Red Hat layer, I think is really the thing that is new, and Power10 is really aimed towards and driven towards. So anyway, I know we're over time.
It's exciting.
Absolutely. Great place to be in. Thank you. Thanks again, everyone.
Thanks, guys.
For people to join.
Thanks, everyone.
See you again soon.